Vapor condensation, just like the name implies, is when you turn a vapor into a liquid. Any process that does that is vapor condensation. So all distillation systems, by definition, have a section where vapors condense. That's how distillation works, where the gaseous product turns back into a liquid. On our 6-inch white film, it looks like this. It's a little finger, but this is water cooled and is good for about 7 liters of condensation per hour. You don't need a lot of surface area, but you do need sufficient cooling power. And in fact, this is usually heated to 80 or 90 Celsius. So even though it's hot, it's cold enough that the product, cannabinoids, condenses on it very readily and at a very rapid rate. And then that heat has to be removed and sent somewhere else, in this case to the environment. There's 3 limiting factors to any condensation system. And this is actually a perfect example of the first one, surface area. This has only 1 finger with a limited amount of surface area. If you start trying to condense more than about 7 or 8 or 9 liters an hour on this condensing surface, you will start getting, there's just not enough time in contact and vapors will go past it and just start exiting to the vacuum system. The second limiting factor is actually the most common, and this is a good example from our cold trap on the 12-inch. This immersion probe only has about 100 watts of cooling power, not a lot at all. It gets very cold, but if you try to condense a lot of volume on it, it will start to warm up and it won't get that very cold temperature that's so important to a good cold trap. And the last one is temperature. Because you have to get to the right temperature to condense the vapors that you want in the system, that's why we have a very powerful minus 55 Celsius chiller as a pre-stage to our cold trap, which has a lot of power, overcoming the second limitation. But it's just not as cold as the minus 100 Celsius. So that's why the minus 100 Celsius is still so important to get that temperature down for those most volatile components. In most cases, you're going to be dealing with a single component condensing, and you're going to run into one of those limitations first, and knowing which one you're going to run into first and how to overcome it is going to help you make a better system.